What's up, guys? Welcome to your first video geometry lesson. This is being recorded just as a way to kind of give you guys a little supplementary resource along to your reading, so that way you guys can have a chance to kind of hear from me, see an example live, because sometimes that helps a little bit. We're going to kind of see how this works. As of right now, I'm planning on doing videos about this maybe once a week where I'm just covering things really quickly, just like when we did packet work, where I would do one lesson and then we have a lot of you guys just working on things. As always, though, I do recommend that you guys ask me questions, use your Discord time, your daily Discord time, as well as once a week maybe I'll host a WebEx session if that's something you guys would like as well. But again, you can always reach me on Remind, email, or even on Google Classroom. You guys can leave comments there, and I'll try to get back to you as soon as I can. So this next section that we're covering is going to be on chapter 12. We're going to be moving on to volumes. Now, technically, a lot of this work, as I mentioned in our little first WebEx session, isn't necessarily mandatory, meaning when we go back to school, I will be recovering all of this, but this is just to give you a bit of a head start so we can move through it a little bit more quickly than we could if we had to just start from scratch. And I think it's a little more fun if we move on to new material than if we just cover the same material over and over again. So with that, let's get jumping in right now to chapter 12. We're going to be talking about volume. So first off, when we're talking about volume is just a 3D counterpart to area. If you're looking at area, you're looking at a 2D shape, so you have things like length and width and so on and so forth. But with volume, we also add this extra vertical element of height. The idea of volume is we're saying how much stuff can I fit into this 3D shape. Just like with 2D shapes, with area, we're saying how much stuff can I fit on top of this surface. With 3D, we're saying now how much can I fit inside of this shape. One thing I do want you guys to focus on is units do matter. In this case, units do absolutely matter. I went over this a little bit when we were doing areas, but because of the time and just how everything ended, I didn't have a chance to go over it too much. So because of that, this section, one thing you do need to remember is units do matter, and I am going to be testing you guys on units a little bit more than I was previously. Okay? Next, when we're dealing with volumes, we treat the units like variables. Again, units do matter. Keep this in the back of your mind. We treat our units like variables. We will be coming back to this, so you don't need to worry about it too much now. We're going to be doing an example problem at the end, and I'll show you what that means, but we treat units like variables, just like we do pi and we do square roots. We treat them just like variables. All right, so jumping in, we're going to be dealing with different shapes. Now, when we're dealing with different shapes, we're looking at how much stuff can I fit inside. So they're all three-dimensional shapes. Just like when we did two-dimensional shapes, we had circles, we had polygons, we had triangles, octagons, all of these different classifications of polygons. And inside of that, we had things like squares, rectangles, kites, rhombuses, right triangles, isosceles, right triangles, all of these different classifications. Similarly, when we're dealing with volume, we're adding new classifications. So the first classification we're going to talk about are prisms. Now, prisms are three-dimensional shapes where they have two congruent bases. So I'm going to be writing that down right now. Prisms have two, whoops, forgot to switch off my eraser, two congruent bases. Okay, that's what defines a prism, is when we have two congruent bases. Now, as you can see, there are two types of prisms, oblique prisms and right prisms. When we're dealing with oblique prisms, my bases are going to be offset a little bit like this, whereas if I'm dealing with right prisms, they're going to be directly on top of one another, kind of like that. So when we're dealing with prisms, oblique prisms are going to be offset, right prisms are going to be directly on top of each other. Now, just like when we did convex polygons and concave polygons, convex polygons were the ones we used more often, and we barely even touch concave polygons. Very similarly, oblique prisms barely come into the scene because they're a little harder to work with, but we do use right prisms fairly often. Now, the main difference that you can tell is if you have a right prism, then the height makes a 90-degree angle with your base, basically. That's the whole idea. Whereas if you look at this obviously is not 90 degrees, and that's kind of the main difference when we're looking at what's the difference between an oblique prism and a right prism. Again, oblique prism, my bases are offset. Right prisms, they're right on top of each other. Now, I've been using the word bases quite a bit, but I didn't actually define what a base is. But when we're dealing with prisms, our bases are going to be this top part over here and this bottom part over here. These are your bases. And my bases are generally made up of polygons. Now, when we're dealing with prisms specifically, they're all going to be polygons. But if I'm dealing with something like a cylinder, which is kind of like a prism, we're going to be dealing with circles. But when I'm saying prism, again, we're dealing with some sort of polygon base, and my polygons, my bases, are going to be congruent. So that's the first big definition you need to know, prisms. Second big definition you need to know are your bases. That's the main parts of your prisms. So again, we have base here, base here, base here, and base here. Those are your major things. The next thing that you need to know is your lateral faces and your lateral edges. Now, basically what's happening is you have the vertices of the bases, these things over here. And once you have them, you are connecting them to the bottom side. So these two vertices are being connected. This line or the segment that connects them, this is called your lateral edge. Okay. Similarly, on my oblique prism, same thing, lateral edge. Now, that's our first major part. My second major part is my lateral faces, and your lateral faces are these rectangle shapes that are made by connecting your lateral edges. So these two shaded regions that I just drew over here, those are your lateral faces. Now on your right prism on the right hand side, you are dealing with 3 lateral faces, and on your left side you're dealing with 2 lateral faces, or excuse me, 5 lateral faces. And it's just based on the number of sides your base has. But again, those are your lateral faces. So again, we have your lateral edge, your base, and your lateral face. Now, the last thing that we need to talk about is your height or your altitude. Your altitude or your height is defined as the perpendicular distance between your two bases. So if we were to look at this over here, this is a 90-degree angle and this is a 90-degree angle purely because of the definition of a right prism. So this here is a lateral edge, but it's also your height. Now, unfortunately, if we're dealing with this over here, we don't know what our height is going to be because my height has to be the perpendicular distance over here. Now, this lateral edge is this slanted part, and as you can see, it forms this right triangle, so there's no way that my hypotenuse is going to be the same as my leg. So because of that, we don't know that my lateral edge is my height, which is why, in general, we don't like to work with these oblique prisms too much. They don't show up too much often either. They're not quite as stable, so when we're dealing with 3D objects, we generally tend not to use them. But again, if you notice, this shape here is going to be a parallelogram. And because of that really nice fact, you could technically draw this over here and figure it out. But again, like I said, generally we don't use oblique prisms too often, so it's just something to keep in the back of your mind. But again, there is a difference between altitude and lateral edges. Sometimes lateral edges are your altitudes or your heights, but that's not always the case. Whenever you're thinking altitude, just like when we did with triangles, it should always be a right angle, a 90-degree angle. All right, moving on. When we're dealing with prisms, we have to learn how to name them. Now again, there's 2 major parts. We're saying whether it's an oblique prism or a right prism. 90% of the time, we are working with right prisms. And secondly, what type of prism it is. And the type of prism is based on its base. So if we're looking at the left, this is an oblique pentagonal prism. Now we say oblique because the bases are off center, and secondly we say pentagonal because if you look at the bases, both of my bases are pentagons, so we say oblique pentagonal prism. Now on the right side we say it's a right triangular prism. Now unfortunately, when we see right triangle, we assume there's a 90-degree angle in my triangle. Unfortunately here, the right is not talking about the triangle, the right is talking about the prism. So we're saying it's a right triangular prism. I don't know what kind of triangle this is. It could be an isosceles, it could be a scalene, it could be a right, but we really just don't know at this point. The right refers to the fact that my bases are directly above each other. There's a 90-degree angle there. Okay, moving on. So just as a quick summary, make sure you know what a prism is, what the main parts are, what are bases, what are altitudes, what are lateral faces, and what are lateral edges. One thing to remember is my lateral edges are not necessarily my altitudes. Whoops, sorry, that's a little bit blocked. Okay, now I'm not filling anything in over here because I want to keep these videos short, but at the same time too, this is a good chance for you to pause and for you to write this down in your notes so that way you guys have it. Now, moving on, when we're dealing with prisms, we also have to know different types of area. There's 2 types of areas I can ask you for with prisms, and the first is lateral area and total area. Now, when you're dealing with lateral area, basically what you're doing here is you're saying, hey, what is the sum of the areas of the lateral faces? So if I'm looking at these parallelograms over here, I have 1, 2, 3, 4, 5 5 of them. And so I'm going to have 5 different lateral faces. If I add them all up, that's going to be my lateral area. Now there is a proof to this, but let's just kind of know for now that my lateral area is equal to perimeter times by height. And again, your height is given by your altitude, not your lateral edge, but it's just perimeter times by height. So whatever the perimeter of your base is, you multiply that by whatever your height is. Now to find my total area is equal to the base times 2 plus my lateral area. Now basically your total area is saying what is the total area if you look at the sides as well as the top and bottom. So it's kind of like if you were painting or wrapping this shape, you would need to deal with all of your different lateral faces, your 5 different lateral faces, plus you'd have to deal with this top and this bottom, and that's basically what's going on over here. We're just putting all of your different parts together. Again, we do have our formulas laid out really nicely over here. Again, lateral area is just that lateral faces. It's all of the areas aside from the bases. Your total area is obviously total, so it's everything. It's your lateral area plus your 2 bases as well. Now, if you notice, I'm not giving you a way to find the area of your bases, because if you're looking at the area of this is an area of a pentagon, and you guys should be able to figure that out by now. That's what chapter 11 was all about. And again, if you're having trouble about that, make sure you ask. Okay. Next, we're dealing with volume. And when we're looking at volume, we're saying how much stuff fits inside. And so the volume formula for a prism is going to be the base, the area of the base, times the height. So what you're doing basically is you're taking your base and you're just stacking it up over and over and over until it builds up to make this kind of prism shape. And because of that, all we're doing is we're saying, hey, if I know the area of the base, I just stack it over and over and over until I get the height. And that's going to give me the area, how much stuff is inside of this shape. So let me give you a quick example. Now, like I said earlier, units do matter. And as you notice, I have 2 different units here. So we're going to put it all together and kind of solve this from here. So what I would like you to do is find the total area and the volume of this shape. Now, this is kind of how it's going to run. One thing that I always do is I redraw my base. Now, if you notice, I wrote 3 feet instead of 1 yard. And the reason why is because if I dealt with 1 yard and 1 foot, we would have different units, and it's really difficult to work with different units. So one thing you always want to do is make sure your units match up first. If you have trouble with that, feel free to let me know, and I can kind of guide you through that as well. But again, one thing you want to do is you always want to draw your base. So to find your total area, we're going to need to find your lateral area plus 2 of your bases. And the way we find our lateral area is going to be perimeter times by the height. So your height in this case is 5 feet, and the perimeter of your base is going to be 3, 6, 7, 8 feet. So 8 feet. Now, at this point, this is where units matter. When we find our lateral area, this is going to give me 40 feet squared. Now, the reason we have feet squared is because if you look, we're saying 8 feet times 5 feet. And I said units matter, and we have to treat units like we would variables. So if this was something like 8x times 5x, we would have to get 40x squared. And the same thing happens here, but instead of dealing with x, we're dealing with feet. Now, for example, if I wanted to add this to something like 10x, could I do this? No, because they're not like terms. So because of that, that's why we have to have these feet squared, because we can't add an area with a side. That just doesn't make sense. So again, with that in mind, we know that my area is going to be 40 feet squared. Now, the question is, how do I find the area of this triangle over here? Now, you guys should have noticed it's an isosceles triangle. So one thing that we can do right away is we can just draw this 90-degree angle here, and it's a perpendicular bisector because of the fact that it is an isosceles triangle. So we're going to have 3, 3, 1, 1, and then basically all we're going to need to do to find the area of this triangle is 1/2 base times height. Now, you know your base is 1 and you don't know what your height is, but it's that altitude we just drew, so we can kind of figure that out right now. So from here, what we're going to do is we're going to get 3, 1, and the way we find this out over here is using Pythagorean theorem. So this is going to be square root of 8. So your height is square root of 8. So what we know is the area of the base equals 1/2 of your base, and your base in this case is 2, times by your height, which is square root of 8. So your area equals the square root of 8. Now, we are not quite done here because we did have to deal with our units. Now, that square root of 8, if you did that, this is going to be in feet. And if you did that too, again, this is going to be in feet. So your area is going to be in feet squared. Now, if you guys are really smooth, oh, whoops, let me block out my face. Now, if you guys were really smooth, you guys would have noticed that square root of 8 can be reduced. So your final answer should be area equals 2 square root of 2 feet squared. So this is the area of one base, and this is your lateral area. So if we plug that into my formula over here, my total area is equal to 40 feet squared plus 4 square root 2 feet squared. And this is your final answer because you can't do anything with that. Now, how did I go from 2 square root 2 feet squared to 4 square root 2 feet squared? Well, it's because we have this 2 over here. Again, we're just plugging it in. So again, went over a lot in this one section, but the reason why I'm going over a lot in one time is we're trying to keep my time on this recording a little bit short, but at the same time too, you guys can always pause, rewind, or ask me questions. Okay, that's my total area. Now, if I want to find my volume, what we're going to have to do is we are going to have to say, okay, what's the area of my base times my height? And again, we found the area of the base, so my volume, I'm going to do it up here. My volume equals 2 square root 2 feet squared times by my height. And in this case, my height is 5 feet. And then when we multiply this all out together, we're going to get 10 square root 2 feet cubed. And the reason why we get feet cubed is, again, feet squared times one more feet. That's feet times feet times feet. That's feet cubed. So there you have it. You have your volume, you have your total area. That's basically it. We also kind of went over how to do units, but again, this is just one problem. It's kind of a standard problem. As always, I give you a really easy, quick problem, and it's your guys' job to work on your homework and kind of find where you're running into trouble and ask me questions. This is just the brief overview. I don't want to make these videos too long. Again, this is about one of the longer ones I'm going to be doing because I did have that intro, I did have that exit, but we are going to try to keep our videos a little bit more on the short side. So if you have questions, use the class hours, the office hours to your advantage. From 2 to 3 o'clock pretty much every day, unless I have a meeting, in which case I'm gonna have to cancel it, as well as maybe once a week we'll do our WebEx meetings. So feel free to use the chat, feel free to use the book to your advantage. This is just a quick overview. Again, we're gonna try to keep it about 15 minutes, but if you have any questions, let me know. Hopefully this works out for you. If you have any comments on the video, like you kind of wish that it was a little clearer or you didn't have to see my face as I was teaching, for whatever that is, just let me know and I'll try my best to kind of adjust. I'm still definitely working a lot on the setup, trying to get the camera right. The lighting's definitely right. I promise I'm not this pale. I do go outside occasionally to soak up the sun during this time, but if not, stay safe, stay healthy, and see you guys later.